Welcome to Mathlink, where we connect the dots. I am Mr. C, and in this particular unit, we're going to talk about multiplying and dividing algebra expressions. So let's get started. Multiplication. Now, in multiplication, the exponents of the literal factor, that means of the letters, do not have to be the same to multiply the values. So we'll show you some examples. There are many different ways that algebra expressions are disguised in multiplication, and I'll show you probably three basic ways that you can see it. So the best way to do this is to look at an example. So let's look at an example. So this is basically saying multiplying, and I'm going to two expressions. Now, we do not have a dot in the middle or an X. It's broken down into two parentheses. So we have 2xy squared. That's one expression. And in between it, we're multiplying it to negative 3x squared y cubed. Again, it's not adding. If it was adding, we'll have a plus between the two expressions. Those two expressions, and in this case, we're multiplying. So know how multiplication looks. So when you multiply algebra expressions, you multiply the coefficients, if there's, and you multiply the letters, each of the individual letters. So as long as they have the same base, and I want you to write that down. You multiply those letters that has the same base. So there's one of them that has a base of x, here's x, and you have another one with a base of y. Okay. So let me show you how we can do this particular problem and how it's look. So when we multiply algebra expression, in this example, I'm going to multiply the 2 and then the negative 3 first. I'll do the exponents first. I mean the coefficients first. Those are the coefficients. So 2 minus times a negative 3 is a negative 6. And then next I'll multiply the x and the x squared. Now, since they're the same base, I just put down x as my base. The base is x. The exponent for the first one, and I'm going to get rid of these lines on the top so you can see it, is a 1. It's invisible, you can't see it, but there's a 1 here and there's a 2. If they have the same base, you add the exponents. So it'll be 1 plus 2, which is 3. Next, I'll write down the base. The next base is y. And then you look at the exponents, which is a 2 here and a 3. Then you add, again, you add the exponents. So what is 2 plus 3 is 5. You only do that with the same base. The base is that bottom piece, those letters that we're looking at this case. And that's actually our answer right there. Negative 6 x cubed y to the 5th power. So I'm gonna give you a few minutes to look at that. Look at how we wrote that. How do we get that? Again, I'm gonna write it again, the answer. So look at it again. It'll be negative 6. Do you agree? It'll be x. So now look at our base is x. And there's an invisible 1 above that first x. So it'll be 1 plus 2 is 3. And then y squared and y cubed, you add the exponents with that same base, it'll be 5. And then that's our answer. And let's circle it. So that's multiplying algebra expressions. So let's do another one. Let's multiply with 3 expressions to see how it's written. So let's say 2xy times, let's say, again, 2, let's say, x cubed y squared. And let's have a z there. Like, oh, Mr. C, you're adding too much. And then let's do another one. Again, this is a 2. And then let's do 3x z cubed. So let's do that. We're going to multiply those three. Listen to what I'm saying. Three expressions. They're multiplied. Okay? Because there's no addition or subtraction sign in between those, so it's all multiplied. So the first thing you're going to do, oh, excuse me. We're going to start with our multiplying our coefficients of each of those terms. So 2 times 2 is 4. 4 times 3 is 12. So in this case, I'm going to write it this way. So this will be 12. And the next thing I'm going to do is the x. So here's an x here with a 1 on top. Here's an x cubed, and here's another x with 1 on top. So here's my base. My base is x. And when you multiply, you add exponents. So I got a 1 plus 3 plus 1. That would give me 5 if my addition is correct. Now let's look at the y. Again, you only do this with multiplication. So here's a 1 with a y to the first. Here's another y, which is with a square, 2, and that's it. So in this case, I'll put down y, and I have 1 plus 2 is 3, and we're done. Now the last thing is we also have, look, don't forget guys, we have a z here. And we also have a z here. And I'm going to triple underline the z's there. And so again, you notice this is z to the first power. You don't see the 1, but we're going to put it there. So it'll be 1 plus 3. Our base is z, and that be 4. And that's our final answer right there. Our final answer was 12, x to the 5th, y cubed, z to the 4th. How come that's my answer? It's because I'm multiplying. Again, it's not adding or subtracting. I'm multiplying 3 terms. So I got to look at all the variables and letters and numbers and combine them. You only combine far as if the bases are the same. If the bases are the same, x is one base, y is another base, z is another base, then you add the exponents. Now let's look at another way of multiplying algebra expressions. Now, how do we know that this is multiplying algebra expressions? Because we have a 3a times, this has 2 terms. Look at that, times 6 plus 2a squared. How do we know we're multiplying? Because we have a 3a, then we have that parentheses. That parentheses helping us out. We're multiplying that 3a to 2 terms in that one expression. Notice what I said. This is expression 1, this is expression 2, but in expression 2, you have 2 terms, 6 and 2a squared. So let's do this. It's a little different than what we did before. So how do we do this? We're going to use something called, again, the distributive property. This 3a, I'm going to write it so you can see it, is multiplied to the 6, and I know you see that because it's right next to it, but it's also multiplied, that 3a, to the 2a squared. Why is that? Because we treat that 6 plus 2a squared as one expression, and that 3a is multiplying all the way across. You don't stop at the 6, you got to go all the way across. If you have 2 terms, you multiply it to 2 terms. If you had 3 or 4 terms, how many terms you had, you got to multiply that 3a all the way through that parentheses. Don't just stop at the 6. So let's do this one. So to do the first one, so we'll look at this, 3a times 6. That will give me, watch what I'm going to do. I just multiply the numbers. So that gives me 18a. 18a. Now, we're going to do the same thing with 3a times 2a squared. Multiply the coefficients, which are the numbers, and let me just put that plus and then change this to blue so we're on the same page. So 3 times 2 is 6. And now don't forget there's an a. So we got to do a times a squared. We know the base is a, and there's an invisible 1 up here. So it'll be 1 plus 2 is 3. And so in this case, my final answer will be 18a plus 6a cubed. Why that is my final answer? Because even though I have 2 terms, these terms are not alike, so I cannot combine them. This one just has a, this one has a cube. Those are not like terms. So that will be my final answer, 18a plus 6a cubed. Let's do another multiplication problem. We'll stay on this, we'll stay on this screen here. So I'm going to give you another one. Let's do another example. Let's say we have 2ab times 3a plus b plus ab, and then we say square. So what I want to do is multiply, and I'm just going to cross this out so you don't be confused with this example here. I'm going to multiply 2a times an expression that has 3 terms. So that means this 2ab must be multiplied 3 times here, here, and here. And we call that the distributive property. Excuse me. So let's start it again. So let's start with the first one. So 3ab times 3a, multiply 2 and 3, which is 6. And we have a and a, so that gives me a, but notice that's a to the first. This is a to the first power, so 1 plus 1 is 2. What happens with the b? The b just stay as b. So the first term is 6a squared b. That's my first term. Now we're going to multiply 2ab times just b. So I like to do the coefficients first. So it'll be 2 times 1, which is just 2. And we have a. There's no other a, so just be a. But now we have b to the first times b. Again, these bases are the same. When the bases are the same, you add the exponents. So that'd be 2ab. So that's the second term. So let's multiply 2ab to the third term, because we got to do that. So that'd be a positive. Do the coefficients, 2 times 1. There's a 1 in front of that a, so that should be 2. That'd be a to what power? What do you think? We got a to the first, that'd be 2a squared. We got b times b to the first times b to the square will be b to the third power, or b cubed. So now you want to look and see, can we combine any of these? Are these any like terms here? You don't look at the coefficients. You only look at the letters to see if they're like terms. A squared b is the first one. Other one is ab squared. Nope, they're not alike. And then the other one have a squared b cubed. So you cannot combine any of these numbers by adding. So I'm going to circle it. And that would be my final answer for that particular problem. Let's look at our last type of multiplication. In this one, we want to multiply 2 expressions, and each of the expressions has 2 terms. Now, there's a unique way how to do this. So this is very important. You try this. 2 expressions, expression 1 and expression 2, and each of these expressions has 2 terms. Here's term 1, term 2 for that one, term 1 and term 2. So when you have something like this, we're going to use a method called the FOIL method. You use it when you multiply, first of all, because we're multiplying 2 expressions. And you do it when you have 2 expressions and has two terms for both of those expressions. It's called the FOIL method. Now the FOIL method, if you're writing it down, I'm going to write down FOIL, and I'm going to erase it. Stands for first, F stands for first, outer for O, I is inner, and D. So our first is F, first, outer, inner, and it's really our last. So D. So when we talk about first terms, let me show you what we mean. And we only do the FOIL method when we express or multiplying two expressions with two terms. So the F will be right here. First FOIL. Those are my first terms. So that's the first term of the first expression, first term of the second. First, and then the outer terms will be, that's the outside term, and here's an outside term. So those are the outer terms that we have. Where are the inner terms? Here's inner, those two. Those are the inside terms. You're going to multiply those together. And then our last terms. It should be not a D, but an L. Excuse me, guys. And so that's my last term of my first expression and my last term of my second. And so that'd be FOIL, not what I had before. First, outer, inner, last. So not a D, but an L. I don't know where the D come from. And so let's look at here, guys. First, outer, inner, last. I know you're thinking about that. So I'm going to let the slide show us how to do this. So the FOIL. So let's do this here. So the FOIL method, F-O-I-L, first, outer, inner, last. So let's do the first terms. The first terms is a 3C times the 4D squared. That's the first term of each of those expressions. Notice what I wrote down. And that's going to equal to, if everybody agree, 12CD squared. Is that correct? That's my first term. This is the first term right here. Now, let's look at the inner terms. First, outer, and so outer and inner. So our outer is here. Again, don't forget that's a negative 2C. So that's, don't forget, so we got to have a negative 2C. That's my outer. So let's see what happens there. So we do 3C times a negative 2C, which equals to a negative 6C squared. And so that's my outer term. My inner term, or terms, will be right here. You put an I. That's the inside terms. That's how you look at it, inside terms. Multiply those, and you go ahead and do that if you want to ahead of time. So 5D squared times 4D squared will equal to 20D to the fourth. Again, you add those exponents when you have the same base. And your last, okay, the L. The L, that's funny. So last here and last here. So what do you mean by last? They're talking about the last terms of each of the expressions. Last. And in this case, it'll be that 5D squared times a negative 2C, which is a negative 10CD squared. FOIL method. First, outer, inner, last. You do with multiplication, and you do when you multiply two expressions that has two terms. Now, when you do this, your final answer, when you write down your answer, would be 12CD squared. That's what I got for this first one. minus 6c squared, okay, plus 20d to the fourth minus 10cd squared. Now, before you circle that, see if there are any like terms. Do you see any like terms? Actually, I see some if we did this correctly. I see, look at this, guys. The 12 CD and the minus 10 CD. Now, make it easier for you to see this, guys. I'm going to put this as a plus, minus, or negative. And so I'm going to combine those two terms, and then I have my final answer. Let's combine those. So that'll be 12 minus 10. 12 minus 10 is 2. So I have 2cd squared minus 6c squared plus 20d to the fourth. And then I circle it. And that's my final answer for this particular problem, because there's no more like terms when we're adding or subtracting. All terms are different. And so we actually end up with one expression with three terms. The coefficients are 2, -6, and 20. Let's look at one more multiplication problem. Again, looking at, we have two expressions we're multiplying. You see the two expressions, and each of those expressions has two terms. So we're going to use the FOIL method. So let's use the first, outer, inner, last, FOIL method. In this case, for our first term, and I'm going to do it this way. So let me write down F. So for F, and sometimes you may want to just write the letters down and then do it. So the first will be here, the 4x squared and the 3x. So that'd be 4x squared times 3x, which gives me 12x to the third power. Remember that 3x, there's an invisible one on top as an exponent for that x. You don't see it, but it's there. The outer will be the 4x and the -2y. So I have 4x squared times a -2y. That gives me a -8 for the coefficients, x squared by itself, and then y. So the inner, which would be what I'm going to do in blue right here, blue here, blue here, and don't forget your signs, is a -3y times 3x, which gives me a -9xy. I like to put x in before y, so it'd be -xy. Bases are different. And then the last, let's do it in green, it'd be right here. It'll be a -3y times a -2y. That gives me a +6y squared. Don't forget there's invisible ones up here. So now we write down our final answer as much as possible and see if we combine like terms. So it'll be 12x cubed, that's the first one, minus 8x squared y minus 9xy plus 6y squared. Before you circle it, look at each other terms. There are 4 terms. Are there any that are like terms? Nope. We got x squared, x cubed, x squared y, xy, y squared. I'm just looking at the letters. Nope. So that's my final answer. I can't combine. And then I circle that in that case. And that will be my answer for that particular problem. Now let's talk about division. We're going to look at a few division problems and that's it. And so for division, you're basically dividing, again, 2 expressions. So here are 2 expressions here. And in these expressions, we have only one term. Hear me, we only have one term. This is an expression with one term, and then we have a negative 2a squared with one term. Now, for division, I'm going to show you one way you can look at it and how to do this particular way. I'm going to rewrite this. We got negative 20 a cubed x to the fifth y squared. That's just one term. There's no addition, subtraction. We had addition, subtraction in there. That gives us more than one term, but that's just one term. And I'm going to write it like this, divided by a negative 2a x squared. Okay, so I'll write it that way. And then what you do when you divide all with the same base. Now, we started with the coefficients. So we have a negative 20 on the top and a negative 2. So divide the coefficients first. So negative 20 divided by a negative 2 is a positive 10. And that 10 is on the top because sometimes you may have some stuff on the bottom. Now you look at the a cubed and the a. And when you divide, you subtract exponents with the same base. A is the same base. And so you do 3 minus, don't forget there's a 1 up here, 3 minus 1. And so that'd be a squared. You look at the x's next. You got x to the fifth and x squared. Same base is x. When you divide, you subtract the exponents. So 5 minus 2, this would be 5 minus 2, in this case is 3. And then for the y squared, there's nothing underneath it. So, and there's no other y on the bottom. So you just have y squared. And then this would be my final answer. It's still one term. And it'd be 10a squared x cubed y squared. Again, rewriting it this particular way may help you see how to divide a little differently. And we'll look at some more problems too. So let's look at another division problem. We know this is division because we have two expressions. Notice I'm saying two expressions. Expression 1, expression 2. This expression has 3 terms, okay? So this has this term, and this term. This one only has 1 term. So when you divide by 1 term into something that may have 3 or 4 expressions, I'm going to show you an easy way how to look at this and how to do this. So what I'm going to do is rewrite like I did before. And I normally do this when you have 1 term on the bottom. So notice how I'm going to rewrite this. 4x squared y cubed minus 8xy to the 4th plus 20x cubed y squared. All that's divided by, since it's in parentheses, all that's divided by 4xy squared. So that's how I'm going to rewrite it. And how I'm going to do this, I'm actually going to divide this bottom term to this first term, to this second term, and to the third term of the top. So you're going to do 3 times division because that 4xy squared that I circle in red is dividing into all 3 of the terms on the top. So you're doing 3 divisions. And this is how you write it. So let's do this. So when we do the first, let's do the first piece here. So for the first piece, we're going to look at the 4 and divide the 4. 4 divided by 4 is 1. And we don't write 1 in front of the as a coefficient. It's like an invisible 1. There's a lot of invisible 1s seem like that's happening. And then, and I just, for right now, I'll put down 1 just so you can see it. Then you do the x and x squared. Since we're dividing, it'll be 2 minus, here we go, there's some invisible 1, 2 minus 1, because when you divide, you subtract the exponent. 2 minus 1 is 1, so that'll just give you x to the first power. So 1 times x. And then you have y cubed, and you have x squared. So those are the same base. With the exponents, when division, you subtract 3 minus 2 is 1. So in the first term will be xy. That's basically what we're going to say is 1 times x times y, or just xy. I'll change it in a minute. Now we'll do the same thing for the second term. Again, this would be a negative 8 divided by 4, which is 2. We do x, the same base. So we got x divided by x. That'll cancel out. So my x's would cancel because it'll be x to the first, x to the first. So it'll be 1 minus 1 is 0. X to the 0 power is 1. So that's gone. Then we have y to the 4th and y squared. So y to the 4th and y squared. We subtract the exponents once we divide. 4 minus 2 is 2. And so that's my second term. Now let's do the third one. For the third one, we'll put it in green so you can see. We got 4xy squared. Do the coefficients. In this case, I'll put it back in blue so you know that. 20 divided by 4 is 5. We have x cubed on the top, x on the bottom. That gives you x squared on the top. You have y squared and y squared, top and bottom. That cancel out. So that's where we stop at, because both of them are square. They cancel out. So if I write this as a final answer, I write down xy minus 2y squared plus 5x squared. Now, the next thing you want to do is make sure these three terms cannot be combined. Are they like terms? They're not. You got xy, you got a y squared, and you got an x squared. So then that's my final answer. And you want to circle it because you cannot combine because there are no like terms. Let's do one more problem, and I'm going to start from scratch for this problem. Let's say we have 20x squared y cubed minus, let's say, 5x cubed y to the 4th. That's my first term. And divided by my second term. You give me a number. Okay, I'll use that number. 5x squared y squared. Okay, so let's do that. If you want to pause this video and see how you can do it first and see if we get the same answer, feel free to pause it right now to see what answer you get. So the first thing I'm going to do is write the problem down like this. So this is two terms, and then this is 5x squared y squared. So what this is saying, since I'm dividing by one term, I'm going to divide this into the first term of the top and also the second term on the top. So let's do that. Start with the coefficients, then the x's, then the y's, to see what happens when they cancel. So 20 divided by 5, in this case, we have 4. We look at our x, we have x squared. We have x squared on the bottom. So x squared and x squared will cancel out because they're basically the same. So there'll be no x there. Now we look at the y. We got y cubed and y squared. The bases are the same. And then we subtract the exponents. 3 minus 2 is 1. So that'll be y to the first power, which we just say y. Remember, there's an invisible 1 there. So we're done with our first expression. So let's do our first term. Let's do our next term. So remember, this is a negative 5, and this is a positive 5. So we have a minus. So 5 divided by 5 is 1. And this is a negative, it'll be minus 1. We have x cubed and x squared. Since the base is the same, we subtract the exponents. 3 minus 2 is 1. So it'll just be x to the first power or x. And then the y, so we have a y. Bases are the same. We got 4 minus 2. 4 minus 2 is 2. So when I'm going to write this, I'm going to say 4y minus xy squared. That's properly how you write it. Now look at those two terms to see if you combine it. And we can't because we have one term with y and the other term with xy squared. Those are terms. And since they're not the same terms in adding and subtracting, we just circle it and that's our final answer. So I hope that helped. Again, look over the video again on how we talk about multiplying and dividing algebra expressions. If you have any more questions, feel free to go on our website, Mathlink website, and look at our supplementary material that we have on our website with this particular subject matter. Again, let Mathlink bring it together.